The scenes you're about to witness depict fatal accidents that occurred while employees were working in shipyards. All identifying references have been removed to protect privacy interests. Please be advised that the depictions may be disturbing and deal with graphic subject matter. A crane operator and two riggers were moving structural sections of a crane boom from a storage area to another area of the shipyard. The riggers were positioned at both ends of the structural sections while they were being transported. After the first section was delivered, the men noticed their original route taken to deliver the first section was now blocked by another working crane. Rather than wait for the crane to finish and move out of the way, they decided to take another route to the worksite. As they transported the second section, the two riggers focused their attention on keeping the load headed straight down the narrow path. All three workers failed to see the overhead power lines. The crane boom contacted these high-voltage power lines. 7,200 volts passed from the power lines through the wire rope into the suspended structural section to the rigger, who was still holding on to the section. The rigger was killed instantly. Let's look at some of the contributing factors that led to this fatality. En route to their work area, the crane traveling with the suspended load struck overhead power lines. A safe route was not established before the crane was moved. A designated person must establish a safe traveling route for cranes. Equipment must not be operated or positioned within 10 feet of an energized power line. The rigger holding onto the load provided an electrical path to ground. Always use non-conductive tag lines to control loads. When practicable, tag lines should be clean and dry. Riggers assigned to assisting the movement of the crane and load must ensure sufficient distance is maintained between the extended boom of the crane and power lines. Ensure riggers are adequately trained to recognize crane hazards. It is recommended that power lines be clearly marked and visible, as well as other overhead hazards. If workplace conditions change, another hazard assessment should be performed to determine whether previously unidentified hazards exist. Although not contributing to the fatality, it is recommended that loads be carried no higher than necessary, normally waist high, to prevent contact with any other obstruction. A truck crane lifts steel shell plates from a staging area. The crane holds them in place on the vessel while they are tack welded in position. After tack welding several steel shell plates, the welder went back to complete the welds on each plate. As the employee completed each weld, the crane continued moving additional plates into position. As the welder worked on the port section, the crane moved plates to the starboard side. The crane lifted each plate and swung it over the hull under construction. The crane operator inadvertently left the auxiliary hoist line partially extended. As the crane swung, the auxiliary line struck the top of a shell plate, snapping it at its tack-welded base. The shell plate toppled and fell onto the welder working below. The welder was crushed to death. Let's look at some of the contributing factors that led to this fatality. The crane operator did not recognize the hazards caused by the partially extended auxiliary hoist line. Crane operators should assess and recognize potential hazards before starting work. Unused slings and lines must be secured prior to moving the load. The crane operator swung the boom and load over an area where the employee was working. Crane operators must never swing loads over employees. The work should be planned and plates pre-positioned on both the starboard and port sides so there is no load passing over the workers. It is recommended that riggers wear a high visibility vest and have available to them an audible device such as a whistle to alert crane operators or nearby workers of unsafe situations. The welder was not aware that the crane had started to swing over his work area. Educate all workers of the hazards around working cranes. Crane operators should keep visual contact with nearby workers. Assign a spotter on the ground to make sure the crane will not interfere with other objects or other work operations. An inactive ship was being prepared for relocation to another pier. 2 men were rigging a chainfall to lift the last of 7 3,000-pound mooring chains in order to secure it along the deck edge of the vessel. One half of the mooring chain was supported part of the way up the side of the vessel. The men were preparing to lift and secure the unhooked end of the mooring chain near the deck edge. The men began by attaching several short wire rope slings end to end with shackles, creating a longer hoisting line. One end of the sling assembly was attached to the unlinked end of the mooring chain. The other end of the sling assembly was led through a bit on the deck edge of the vessel and then attached to a chainfall. As the chainfall pulled its maximum distance, the sling assembly was secured to the bit by manila rope used as a stopper. The chainfall was then slackened so that the chainfall hook could be attached to the next sling shackle through the bit. As the second sling was pulled by the chainfall, the sling shackle got hung up on the bit. The sling assembly was secured with a manila rope stopper, and then the chainfall was backed off. While waiting for instructions, the worker walked into the area and looked over the deck edge to see what was wrong. The manila rope stopper snapped, causing the weight of the chain to be transferred back to the sling assembly. The slack assembly suddenly became taut and struck the rigger in the neck with tremendous force, breaking his neck. The rigger died instantly. Let's look at some of the contributing factors that led to this fatality. A hazard assessment was not performed before the work began. Riggers were not properly trained to perform the tasks they were assigned. The sling assembly used was not properly sized for this hoisting operation. For this job, only slings that fit through the bit should have been used. A safety line should have been attached to the end of the mooring chain to support it if the hoisting apparatus failed. Always use the proper equipment for the job. The employee entered the bight of the line while the line was under load. Never enter the bight of the line. The crew relied on manila rope as a stopper. The load on the rope exceeded the safe working strength of the rope. Never exceed safe working loads of rope, line, or chains. Two workers were assisting a crane operator who was loading a piece of equipment from a pier onto a ship. The ship's crane was being used to transfer a heavy delivery valve onto the ship for installation. The workers were positioned on 2 unguarded catwalks that ran along each side of the ship's open hopper. The workers used tag lines to guide the load onto the ship's deck. As the crane swung the load from the pier to the ship, the load disengaged from the hook. The load fell and struck the starboard side catwalk near one of the workers. The startled worker on that catwalk quickly stepped back away from the falling load and lost his footing and fell, hitting his head on the catwalk as he went down. Unconscious, he fell into the hopper, which at the time was filled with water, and drowned. Let's look at some of the contributing factors that led to this fatality. The valve was not properly rigged to the hook of the crane. Always ensure that the load is properly rigged to prevent the load from becoming disengaged from the hook. It is recommended that hooks be equipped with a safety latch or moust. Actions were not taken to ensure adequate fall protection was provided to workers along unguarded edges. Employees working on elevated catwalks must have adequate fall protection. In required order, such protection includes guardrails, fall arrest systems, or if employees are working over water, personal flotation devices. A dive team was asked to install J-bolt patches as a temporary repair for 2 holes in a crude oil tank barge. The 2 holes were at a depth of approximately 25 feet. The dive team consisted of 2 scuba divers and a diving tender to control the safety lines from the pier. The 2 divers entered the water to remove a wooden plug from the first hole and install a J-bolt patch. Both divers had safety lines attached. After installing the patch, both divers returned to the pier and exited the water. Diver number 1, wearing blue, remained on the pier, while diver number 2, wearing yellow, re-entered the water by himself to tighten the first patch that was installed. Diver number 2 had a safety line attached for this dive, but the line was not tended. After tightening the patch using a pneumatic wrench, diver number 2 exited the water. On his third dive, diver number 2 re-entered the water by himself to move the air hose, safety lines, and magnets from the location of the first patch to where the second patch would be placed. The air hose and safety lines were attached to the hull of the ship with a magnet. Diver number 2 did not have a safety line attached because he was relocating it. Diver number 2 had been in the water for over 10 minutes, while diver number 1 was on the dock mixing epoxy. He called the tender off his break to help him with preparing a patch for the second hole. When the tender returned to the dive location to assist diver number 1, he noticed that the air hose and safety lines were not attached to the hull, indicating that diver number 2 failed to reattach the lines. He became suspicious that something was wrong. Diver number 1 put his scuba equipment back on and entered the water to find diver number 2. Visibility was very poor, so diver number 1 could only search by feeling with his hands. After a search of approximately 10 minutes, diver number 2 was found unconscious and was removed from the water. Diver number 1 attempted to resuscitate diver number 2 by performing CPR. His efforts were not successful. Let's look at some of the contributing factors that led to this fatality. While in the water, scuba divers must always be tied to a safety line and line tended from the surface, or accompanied by another diver with continuous visual contact at all times. A standby diver must be ready to provide assistance whenever a scuba diver is in the water. Scuba divers must carry a reserve air breathing supply. When line tending from the surface, a tender must never leave his post. The designated person in charge must not let other tasks detract from his prime responsibility, the safety and health of dive team members. 2 workers were told to pump out the bow compartment of a barge that held 12 inches of water. The on-deck pump they would normally use was being repaired, so they decided to use a smaller gasoline-powered pump inside the compartment. The compartment had only one open access hatch that the workers used to enter the space. The gasoline-powered pump was set up inside the space, and one worker remained with it to make sure that the intake hose stayed submerged. Exhaust gases from the gasoline-powered pump containing carbon monoxide built up in the space. The workers slowly became unconscious and eventually fell face down into the water that remained in the space. The other worker on deck did not know there was a problem because the pump was running continuously. Later on, when the pump ran out of fuel and stopped running, the worker on deck went down into the compartment and found his co-worker face down in the water. Let's look at some of the contributing factors that led to this fatality. Confined spaces must be visually inspected and tested by a competent person to determine the atmosphere's oxygen content prior to an employee's entry. Employees entering confined or enclosed spaces must be trained to perform their work safely and to recognize hazards. When using internal combustion engines exhausted below decks, the space must be periodically tested by a shipyard competent person to ensure that dangerous levels of carbon monoxide do not develop. Ventilation must be provided to maintain the oxygen level and keep carbon monoxide below hazardous levels in spaces where internal combustion engines are used. Workers in confined or enclosed spaces or in isolated locations must be checked frequently. An electrician was working on an open electrical panel on a ship. He needed to add a new cable and attach it to a breaker within the panel. The electrician identified the isolation breaker that fed the entire panel on the schematic drawing. The electrician de-energized the breaker and properly tagged out. As the electrician was fitting the new cable into the panel, his left hand came into contact with the panel's main bus bars. 440 volts of current passed from the bus bars through his left hand, across his chest, and out his right hand that braced him against the panel, electrocuting him. At some point, the tagged-out isolation breaker had been cross-wired with another breaker. The electrician did not know that the panel he was working on was never de-energized. Let's look at some of the contributing factors that led to this fatality. Employees should verify the location of all energy isolation points. Employees must check or test electrical panels or electrically powered equipment to ensure they are, in fact, de-energized before working inside them or within the vicinity of exposed electrical circuits. Inform all contractors and subcontractors of the ship's systems and/or modifications to the systems prior to beginning work. A shipyard worker was preparing to replace a high-pressure steam valve that was faulty and leaking in an engine room. The valve was part of a 600 psi steam system on a vessel. Other shipyard personnel had previously located all the valves and drains and isolated the steam system according to the ship's as-built drawings. All the drains indicated on the as-built drawings of the ship were opened and depressurized. The drains were then marked with tags. As one of the workers loosened the bolts around the faulty valve, a tremendous burst of steam was suddenly released. The steam under high pressure at 385 degrees Fahrenheit knocked the worker to the ground and produced third-degree burns on more than 60% of his body. The worker died 2 days later in the hospital. Errors and omissions on the ship's as-built drawings had prevented shipyard personnel from completely isolating and draining the steam system. Let's take a look at some of the contributing factors that led to this fatality. Use a thermal gun or carefully place your hand near both sides of the valve to check the temperature. Verify that the steam system is drained and the drain valve is open. Be careful not to touch the pipes or valve too quickly. Approach them slowly to feel if heat is radiating from them first. If they are very hot, then they may still contain steam under pressure. Accurate drawings free from discrepancies are essential for effective energy isolation. Shipyard personnel should be properly trained to conduct a visual check of all drains and valves in a steam system that is to be drained and depressurized. Drain connections on all dead interconnecting systems must be opened and observed to ensure effective isolation. Employees authorized to perform steam system repairs should be directly involved in the isolation and lockout-tagout of the system. Direct involvement by workers in the lockout-tagout process ensures their understanding of the operation or process hazards that the lockout-tagout is designed to control and how to avoid or control these hazards. It is essential for ship's personnel and repair contractors to communicate and coordinate about the isolation and lockout-tagout of the ship's systems. We urge you to think about the accidents you just saw and to use that information to make your job safer. Don't add your name to the list of fatalities. And remember, all shipyard workers must wear or use equipment necessary to protect them from occupational safety and health hazards. Such equipment may include hard hats, safety glasses, protective footwear, gloves, long-sleeve shirts, long pants, hearing protection, and a flashlight or light stick. If you are asked to perform a task that you believe is unsafe, or you are asked to perform a task in an unsafe manner, or in a manner that violates OSHA regulations, ask your supervisor or employer for help in determining the correct and safe way to proceed. You can also contact your local OSHA office for help or visit the OSHA website at www.osha.gov. Employers can request a free on-site consultation visit and obtain additional information by contacting their local OSHA office or through the OSHA website. If you have an emergency, need to report a fatality, or a workplace hazard that poses a threat to health or safety, or want to file a complaint, please call OSHA's toll-free number, 1-800-321-OSHA.